Sum and difference identities of cosines. So these are some good examples of a diagram and explaining to you the cosine and sine formulas and where it falls at on the unit circle. So we have a difference of cosines. These are going to be what you need for this section. Pay attention that if it's cosine alpha plus beta, we get a minus here. If it's cosine alpha minus beta, we get a plus here. And then we got our cofunctions. You need to know these because we will use these, okay? Example 1, express the given angles as beta plus alpha plus beta or alpha minus beta, where cosine alpha and cosine beta are exactly 11 pi 12ths. So what we need to do is figure out which one of these here is the correct choice. So it's a good measure of elimination, because if you take that 5 pi fourths and add it to pi thirds, well, we know that we need a least common denominator, which is 12, which is check, that's what we need. So this one has to be multiplied 3 and this one by 4. So now I got 15 pi plus 4 pi all over 12. Well, 15 plus 4 does not give me 11. So we're going to say no to A. Let's check the next one. 5 pi over 2 minus 2 pi over 3. We need it to be 12. So I'm going to multiply this one by 6 and this one by 4. So now I got 30 pi minus 4 pi. Well, we can stop right there because nope, that's not going to give me 11 in the numerator. The next one, we're going to take the 5 pi over 4 minus pi over 3, multiply this by 3 and this one by 4. And I get 15 pi minus 4 pi all over 12. This works because 15 pi minus 4 pi is 11 pi over 12. So check, this would be my answer. Okay, the next one, we're going to use the appropriate identities to find the exact expression. So we have cosine of 105 degrees. And if we go to our unit circle and we look at our degrees and find the ones that add up, we'll notice that 60 degrees plus 45 degrees does give me 105. So now I can use this formula of cosine alpha plus beta. And that's equal to cosine of alpha times cosine of beta minus the sine of alpha, sine of beta. And now we know what it is. Well, I know that cosine of 105 degrees is cosine of 60 degrees plus 45. And now I can plug it into our given formula. So my alpha is going to be 60 degrees. My beta is going to be 45 degrees. Okay, and then we'll figure out, you can go back to the unit circle to figure this out. Cosine at 60 degrees is a half. Cosine at the 45 degrees is square root of 2 over 2 minus sine of 60 degrees is square root of 3 halves times sine of 45 degrees is square root of 2 over 2. And we're just going to finish this up. Now I got 1 times the square root of 2 over 4, because 2 times 2 is 4, minus square root of 3 times square root of 2 is square root of 6 over 4. And let's just rewrite it where it's a little bit neater. And that is our answer. Okay. Use the appropriate identity to find the exact value of the expression of cosine 13 pi 12ths. So here we go. We can go to the unit circle and find the exact radians. So we can come up with, let's say, pi 6, 5 pi, let's see, 5 pi 4, pi fourths, pi thirds, pi halves, and so on. I mean, we can pull them all out if you need to. What we need to do, though, is we got to find what's going to give me 13 pi 12ths. So I want to start, let's start with the 5 pi fourths. And let's subtract the pi 6. Okay, we gotta have a common denominator, which is 12. So I'm gonna multiply top and bottom by 3, this one by 2. So I got 15 pi minus 2 pi all over 12. 15 pi minus 2 pi is 13 pi, 12. So that gave me my answer for what we're gonna use for alpha and beta. Okay, and I'm gonna pick the bigger one for alpha. So now let's finish this up. So now that I know that, I can rewrite this as cosine of alpha, and we said 5 pi fourths plus the, or minus, let's do the minus because we had to subtract. Let's do the minus of pi fourths, or 6 pi 6. And then that gives me cosine of 5 pi fourths, cosine of pi 6, sine of 5 pi fourths, sine of pi 6. Okay, so now we go to the unit circle, find out what these exact spots are. We get a negative square root of 2 over 2 times square root of 3 over 2 plus, because we're using a minus here, a negative square root of 2 over 2 times a half. And let's just clean this up. So now I get square root of 2 times square root of 3 over 4, because 2 times 2. Negative times positive is a negative. Square root of 2 times 1. 2 times 2 is 4. Negative square root of 6 minus square root of 2 all over 4. And that will be our answer. Okay, now let's go to the next one. Simplify the following expression by using the appropriate identities. So what do I notice? Have alpha is 26, correct. Beta is 67, so we did good. We know that there's a plus here, so then that means the cosine will be a alpha minus beta. And so now let's plug it in. We know what alpha is. It's 26 degrees minus my beta, which is 67 degrees. And when we subtract those, we get a negative 41 degrees. However, cosine is even. So this right here just goes away and we got cosine of 41 degrees. If it was an odd, we'd bring it to the front. And that is our answer. Okay. Simplify the following expression by using appropriate identities. Do not use a calculator. So we know what alpha, we know what beta is here, and they both are correct. Okay, so that looks great. So now let's just write it in. We got cosine of 7 plus 5, which is cosine of 12. And that is our answer. This next one here, we're going to use a co-function identity. All right. So the co-function identity tells me that sine of u is equal to cosine of 90 degrees minus that u. Okay, and that's, see, we got sine here. And we know what u is 68 degrees. So knowing that, I can go cosine of 90 degrees minus that 68 degrees. And it gives me, cosine, erase my writing here, of 22 degrees. So we get 22 degrees here. All right, let's do our next one. Use the co-function identity to identify the blank spot here. So we got cosecant here. So whenever you go to our formula sheet, we know the cosecant of u is equal to the secant of pi halves minus u. And if you notice, our u is pi sevenths. So I got secant pi halves minus pi sevenths. And in order to subtract these, I need to have a common denominator. And in this case, it will be 14. So it's going to be 7 over 7. So I got 7 pi over 14 minus 2 pi, which is secant 5 pi over 14. So 5 pi over 14 is our answer for the secant. Okay. So now let's simplify the following expression by applying the odd and even identities and co-functions. If you notice that sign is odd, so that means this negative needs to come out here, and that causes it to become a negative there as well. And let's just rewrite it. Also notice that we have some things that are not exact here. We have a alpha, or excuse me, we have a beta of 12 degrees here. And a beta of 78, and we have a cosine instead of a sine here. So let's do some work. And so in order to do the work, we're going to use, and if you notice this table will be very useful for you to memorize or have on a flashcard. All right, so what we're going to do is we got cosine of u is equal to sine of pi halves minus u, where we also know pi halves is equal to 90 degrees. So we can just say sine 90 degrees minus the 78 degrees, which gives me sine 12 degrees. All right, so we can rewrite that, the original again. So now we got cosine 18 degrees, cosine 12 degrees, minus sine 18 degrees times sine 12 degrees. And now that we have that, we can use the formulas that based upon what we got here to complete this. Since we have a negative here, we're going to use the cosine of alpha plus beta. So when I do that, I'm going to rewrite that. So it's cosine of 18 degrees plus 12 degrees, which is cosine of 30 degrees. And when you go to the unit circle, that the exact position is square root of 3 halves, your exact answer. All right, so let's finish up. Find the exact value of cosine alpha plus beta when we're giving sine of alpha and sine of beta. It says alpha is in the 4th quadrant and beta is in the 2nd quadrant. So let's solve for this. What we're going to do is we notice we're at cosine here. So let's go get that identity. The cosine squared of alpha equals 1 minus sine squared of alpha. And since we know what alpha is, let's just go ahead, or excuse me, sine is, let's just plug it in. Sine of alpha is going to be that negative 4/5. So negative squared is positive, 4 squared is 16, 5 is 25. Now we need a common denominator, which is 25. So 25 times 1. So I got 25 minus 16 all over 25, which gives me 9/25. Okay, so now let's find cosine. We got cosine squared of alpha. So what we're going to do is we're going to square root both sides. When we square root both sides, we get a plus or minus. So now I got cosine alpha is equal to 3/5, 3/5. And since the alpha falls in the 4th quadrant and cosine is positive in the 4th quadrant, then our answer here is just going to be positive. So we have 3/5. Let me just rewrite that little meter. So in the 4th quadrant, cosine here is positive. So that's why we kept it positive. Next, let's find the beta. So what I'm going to do is just take the cosine squared of beta, set it equal to 1 minus the sine squared beta. Plug in what I know for beta for sine and square it. We got 12/13. So now I got 1 minus 144 over 169, and common denominator is 169. So I got 169 minus 144, all divided by 169. And that gives me 25 over 169. Okay, so now I got the cosine squared of beta equals 25, 169. I'm gonna take the square root of both sides. Remember, since it's an even root, we get plus or minus. So now I got cosine beta is equal to plus or minus 5 over 13. So what I need to do now is determine, is it negative or positive? Well, beta cosine in the second quadrant is negative. So it's right here, it's negative. So we're going to keep the negative. All right, so we are almost done. So now I'm going to take the cosine of alpha plus beta, and we're going to plug in. I got the 3/5 plus the 5/13, negative 5/13. And since it's minus, it's a negative times a positive, we're just going to put in a minus here. Okay, in order to do this, we need to have a common denominator. So we're just going to multiply. Let me make myself more room. I'm going to multiply this one by 13 over 13, because 13 and 5 are both prime, so it's just might as well multiply them by each other. All right, so 13 times 3 is 39. 13 times 5 is 65. 5 times 5 is 25. And now we are going to say the 39, I believe it's 14, 39 minus 25. Yes, it is. So it leaves me with 14 65s. And that is our final answer.